Hello my dear students, this video is about some important formulas of surface areas and volumes, and then after completing the formulas and memorizing them, we will apply those formulas to solve the questions in exercise 13.1, 13.2 and 13.3 as well, right? So let us discuss the formulas starting with cube. Important formulas, or we can say formulae. The first figure is cube. As we discussed it earlier, cube is a special type of square prism. This is cube, right? Let its side be equal to A units. Am I clear? So what will be the first? First, we will discuss about the total surface area. Total surface area. That is simple. It's one side area, second side area, and third side, and then fourth, fifth, and sixth. Total surface area is equal to 6A square units, because there are 6 sides in it. Second, then we have its volume. Volume will be definitely be equivalent to A cubic units, right? Then we have the third formula of this, that is the LSA, lateral surface area. The question is, what is the lateral surface? Total surface, we know it's the total, right, left, top, bottom, front and back. But what is the lateral surface? Lateral says what it means basically. You have to measure the area like this in a complete one rotation. If you measure like this, that means this surface, front surface, this surface and back surface. Or there is a second chance in it. If you rotate, if you measure like this, then it's a top, front, it's a bottom and back, right? It is, that means it will cover only 4 areas. If I like this, cover front, back, top and bottom. And if like this, then again 4. So it will be simply 4A square units. 4A square units. Then we have its diagonal. That is equivalent to root 3A units. But the question is, what is the diagonal and how many types are diagonal in there? There are 2 types of diagonals. One is known as diagonal. One is known as face diagonal. And second is known as body diagonal. Face diagonal means if you put a front face, this is a corner and this is the opposite corner. The length which connect this point and this point, this is known as a face corner. But if I take this room, that corner and this corner, opposite corner, this is known as a body diagonal because it passes through the 3D surface. This passes through the body and this is known as a body diagonal. And this is the longest edge in this 3D. If I take this room as a cube, the longest length is a body diagonal, which is from that corner to that corner. This is known as a body diagonal. If I talk about the face diagonal, it is simple. I have the surface here, right? This is a plane, rectangular plane, right? This corner and this corner. If I join them, this is a what? Face corner. This is a 2D. Am I clear? But if I talk about the 3D, that corner to this corner, it is a body diagonal. Let us move on. This was about the cube. Total surface area equal to 6A square. Volume is equal to A cubic units. Lateral surface area is equal to 4A square. Diagonal is equal to root 3A. This is a unit, and diagonals are of 2 types, face diagonal and body diagonal. Then we have cylinder. Before writing the formulas of the cylinder, I will discuss a most important point. Solids are basically of 2 types there. One is known as a right circular, or second is known as a oblique. What does a right mean and what does oblique stand for? Suppose you have a surface here, it's like this, and if the axis if the axis is making 90 degree with the base, 90 degree with the base, this is known as right circular, or whatever the figure is. It can be cone, it can be cylinder, it can be cube, but the axis must be at a 90 degree with it. If the axis is not 90, it makes an angle. It makes an angle. Suppose you have a cylinder. Cylinder is here. You have a circle, bottom circle. You have a top circle, right? The top circle and the bottom circle, their axis is perpendicular to each other. That means if I compress them, they will make one circle. If I extrude them, they will make two circles, but equal in shape. But if the case is like this, I have a top circle and a bottom circle. They are just like this, offset. One is here and one is here. That means this circle and this circle, they are connected like this. They are connected like this. That means this axis and this axis between this circle and this circle, that axis is not making 90 degree either with this circle or with this circle. This is known as the oblique solids. When the solids are having the axis which does not make 90 degree with the base, they are known as the oblique solids. But those solids which have the axis making like this, you have the circle here, you have the circle here, they are making the axis 90 degree with the base and the top, they are known as a right circular what? Solids. So I will discuss here not oblique. In our syllabus we don't have the oblique, we have the right circular cylinder. Right circular cylinder. How it look? It look like this. Right? Bottom circle, top circle, and curvature, curved surface. Here, from this point, this is known as the height, denoted by h, and from this point to this point, this is known as the r. R is radius, which is denoted by the small r, and h its height. Am I clear? So first formula, we have to just memorize this. First formula is its volume. Its volume. That is a pi r square h cubic units. Pi r square h. Pi r square h. Second formula. Second formula is curved surface area. It's curved surface area. That's equals to 2 pi RH. 2 pi RH square units, not cube, because R and H are the two dimensions. There's the R square and H, definitely it will be cubic centimeter, cubic units. Then we have the third formula. Third formula is total surface area. Total surface area. Simple. Total surface area means this curved surface area plus the surface area of the top circle and the surface area of the bottom circle. Simply, it is a 2 pi RH plus, it is a curved surface area, plus pi r square plus pi r square, because pi r square is the area of circle, top circle and the bottom circle. This is 2 pi RH plus 2s pi r square. So 2 pi r is common, h plus r. What? Total surface area. It will be the square units. Clear? So it's 2 pi r into h plus r is the formula for the total surface area of what? Right circular cylinder. Once again, volume is equivalent to pi r square h cubic units. Total curved surface area is equal to 2 pi rh square units. Then we have the total surface area is equal to 2 pi RH, that's the curved surface area, plus the surface area of the top circle and the bottom circle, that's the pi r square plus pi r square, that's the 2 pi r square. And this is a simple mathematics, 2 pi r common h plus r. Clear? Now let's move on to the for the third object, that's cone. Right, so it will look like this on a 2D surface. This is perpendicular height. This perpendicular height we denote as h. This is a height of cone. This point we discussed it. It is a apex point, right? From this, there is a center of circle. We all know this. This is a radius, and this length, this we know as slant height, denoted by L. So what is the first formula for this? We will write volume of cone. Volume of cone, that's equivalent to 1 by 3 pi r square h cubic units. Cubic units, what does that mean? It means meter cube, centimeter cube, whatever it is, millimeter cube, right? Then h, it is a perpendicular height, and r, this is the radius, and pi, we all know this. Then second is what? It is a curved surface area. Curved surface area of cone. Curved surface area of cone. Curved surface area of cone, this is equal to pi r L. Pi r L square units, where L stands for slant height, and L is equivalent. L square is equal to r square plus h square, or which implies L is under root of r square plus h square. But the question arises here, where from this formula come? Look here, this is cone, right? If I just make this triangle out of from the cone, and I will draw it here. What is this line? This is h. What is this line? This is r, right? This is a what? Right angle triangle. So we can definitely use which formula? Simply hypotenuse square is equal to b square plus perpendicular square. That is a Pythagoras theorem. This is what? Slant height. So L square is equal to r square plus h square, or I can say L is equal to r plus h. So this formula becomes, it will be pi r and what? Under root of r square plus h square units. So this is about. Now we have the third, that is total surface area of cone. Total surface area of cone means its curvature and the surface area of the bottom, because it don't have the upper circle. Upper circle, that's a cylinder. Upper and bottom circle, that's a cylinder, and bottom circle only, and then curvature, apex point, that's a cone. What is the total surface area then? It will be definitely curved surface area. Curved surface area equal to pi r L plus surface area of what? Circle, that's a pi r square. Clear? So it will be pi r here, it will be pi r L plus r square units. We'll repeat it. This is a cone, figure of cone. Volume is equal to 1 by 3 pi r square h cubic units. Its curved surface area of cone equal to pi r L, and L we know, we have just done that. L square is equal to r square plus h square. L is under root equal to under root r square plus h square square units. Then we have total surface area of the cone, that's a pi r L plus pi r square. Pi r is a common term, and L plus r. This is all about the three formulas about the cone. Let's move to the sphere now. Sphere. Sphere is like this. On the 2D figure, I can draw a circle, but I will just do the hatching process. This is known as a hatching. This is done at an angle of 45. This is known as a hatching process, right? So this is the center, and this is simply r, and r is radius. What is the first formula? First formula is its volume. Volume of sphere. That's equivalent to 4 by 3 pi r cube cubic units, right? It's volume. Second formula is its area, means surface area. Surface area, that's equivalent to 4 pi r square units. That's equal to 4 pi r square. Sphere is here with radius r. Volume of sphere, that's equivalent to 4 by 3 pi r cube cubic units. Its surface area, that's equivalent to 4 pi r square units. This is about the sphere. Now our last figure, that's hemisphere. That is a half of sphere. Hemisphere. Hemisphere. On 2D board, I can draw the hemisphere like this. Right? This is a hemisphere. Here, this is the center of the circle, and this is R, and this also will be the R. Am I clear? This is a hemisphere. The first formula is volume of hemisphere. Simply, it will be the half of the volume of the sphere, hemisphere. And the volume of sphere was 4 by 3 pi r cube. 4 by 3 pi r cube divided by 2, it becomes 2 by 3 pi r cube. 2 by 3 pi r cube cubic units. This is the volume of hemisphere. Then it will be a total surface area. Why? Because you have the two surfaces here. In the sphere, we have only one surface. That's why we don't write the total surface area. We write only surface area. But here you have a circle, one surface, and then you have the curvature, right? The total surface area, that will be equal to the surface area of hemisphere, right? Surface area of hemisphere is equal to 2 pi r square. That's a 2 pi r square plus pi r square. That's equivalent to 3 pi r square. That means total surface area is equal to 3 pi r square units. And third is what? Surface area, not total surface area, only curved surface area. That's the surface area, or we can write it curved surface area. That's a 2 pi r square units. So again, this is a hemisphere. The figure is here. Volume of hemisphere equal to 2 by 3 pi r cube cubic units. Total surface area equal to that's the total curved surface area plus the surface area of the what? Circle. That's a 2 pi r square plus pi r square. That's equivalent to 3 pi r square, and the surface area is equal to 2 pi r square. So these are the few examples which are supposed to use in this chapter, and these are the what formulas which are supposed to memorize to do the questions in exam in this exercise 13.1, 13.2, 13.3, and so on. Okay, so this chapter is based on these formulas. We have to first memorize these formulas, and then we have to go forward. Thank you.